I'd like to call our colleague Shahram Shahabi.
Hello, everyone. I'm a director of research at the Standard Homeopathic Company in Los Angeles, but previously I was a faculty member at the Department of Immunology at Urmia University of Medical Sciences, Iran. The title of my presentation is Subcutaneous Isopathic Immunotherapy of Allergic Asthma in a Mouse Model of Allergic Asthma. So as you know, isopathy is an approach of homeopathy in which the causative agents or products of a disease are used to treat the same disease. Some studies have, until now, some studies have evaluated the efficacy of isopathic, or we can call it homeopathic, allergen immunotherapy or in the treatment of patients with respiratory allergic diseases. Most of them, but not all, showed that this type of immunotherapy, isopathic immunotherapy, was effective. And as you know, in isopathy and isopathic immunotherapy, the remedies are prepared in the same way and method as homeopathy. But the method of diagnosis is different. In isopathic allergen immunotherapy, the method of diagnosis is the same as conventional allergen immunotherapy because we want to find the causative agent, that is the allergen. So we use allergy skin prick test and or serum-specific IgE test. Regarding the diagnostic method that isopathic allergen immunotherapy uses, maybe it's a suitable candidate to address the main issues that currently limit homeopathy. I mean, the therapeutic effect in a highly diluted remedy, and more important, the mechanism of action. And one of the other benefits of isopathic allergen immunotherapy is that we can use animal models. When we use animal models, we can control the conditions. So the possibility to have a repeated results is higher. And for the allergy and allergic disease, the most suitable model is our mouse model because the immune system of mouse is very similar to human. In the current study, we evaluated the efficacy of isopathic immunotherapy with highly diluted ovalbumin in the treatment of ovalbumin-induced allergic asthma in BALB mice. So we divided mice into the three groups. In the high dilution or HD group, we induced allergic asthma, and after that, mice received isopathic treatment. Isopathic treatment was administration subcutaneously 20 microliter of homeopathically prepared ovalbumin 6C. No treatment group. We induced allergic asthma in the mice, but mice didn't receive isopathic treatment. They just received 20 microliter of normal saline. For normal group, the healthy mice, they didn't receive the induction of allergic asthma, and they just received normal saline as the treatment. So this slide showed briefly the course of experiments, sensitization, treatment, challenge, and other things, but I don't want to go into the detail because of the shortage of the time. So, inflammation. As you know, inflammation plays an important role in the mechanism and pathophysiology of all kinds of asthma, including allergic asthma. And every treatment that aims to control asthma can control inflammation too. So we evaluated the inflammation, and as you can see in this slide, isopathic immunotherapy statistically significantly reduced the inflammation score in the lung tissue. And you can see the effect of isopathic immunotherapy on the inflammation in digital image 2. Eosinophils. Eosinophils play an important role in the pathophysiology of allergic asthma. So we evaluated the percentage of eosinophil in the bronchoalveolar lavage of mice. As you can see in this slide, isopathic immunotherapy significantly reduced the percentage of eosinophils in the bronchoalveolar lavage fluid. So IgE and IgE-mediated hypersensitivity to allergens, to antigens, is the most important mechanism underlying development of allergic asthma. And you can see the effect of IgE in the pathophysiology of asthma, and it is the most important factor in the degranulation of mast cells here. That is the most important pathophysiological factor in the development of allergy, all kinds of allergies, including allergic asthma. So, and as you can see in this slide, homeopathic or isopathic immunotherapy significantly reduce the concentration of ovalbumin-specific IgE in the serum. In the course of development of allergic asthma, in the pathophysiology of allergic asthma, deviation of immune system toward T helper 2 and production of T helper 2 cytokines like interleukin-4 is very important. So we evaluated this cytokine. We cultured splenocyte in the presence of ovalbumin for 72 hours. And after that, we measured the concentration of interleukin-4 in the supernatant. We did the same procedure for the measurement of transforming growth factor beta that I will speak about it later. As you can see, the isopathic immunotherapy significantly reduced the concentration of interleukin-4. The most important mechanism by which conventional immunotherapy can treat allergic asthma is induction of regulatory T cells and its main cytokine, transforming growth factor beta. So, in sake of looking for the mechanism of action of isopathic immunotherapy, we evaluated the ovalbumin-specific regulatory T cells and its main produce cytokine TGF-beta. So as you can see in this slide, isopathic immunotherapy increased the level of transforming growth factor beta, but this increase wasn't significant. As you can see in this diagram, isopathic immunotherapy increased the population of regulatory T cells, but again, this increase wasn't significant. So, for discussion, at first, our studies showed that isopathic immunotherapy with ovalbumin in ovalbumin-induced allergic asthmatic BALB mice significantly reduced the severity of asthma. But what is the mechanism? So before talking specifically about the mechanism of action of isopathic immunotherapy, I want to say whatever in the high diluted ovalbumin or every homeopathically prepared remedy is a small amount of original molecules, aqueous nanostructure, electromagnetic waves, nanoparticles, or other things that we don't know. I don't want to talk about this. It should produce a mild stimulation. So, target cells of isopathic immunotherapy should have two characteristics. They should have a low activation threshold that this mild stimulation can activate them, and they should have regulatory functions or could activate other cells with regulatory functions to treat and control allergic asthma. So regulatory T cells are very good candidate. They have regulatory functions, they have a low activation thresholds. And they are the main mechanism by which conventional allergen immunotherapy can control asthma, allergic asthma. But they cannot play a key role in the mechanism of action of allergic isopathic allergen immunotherapy. Regarding the concentration of the allergen that exists in the remedy prepared for isopathic immunotherapy. Because the stimulation of regulatory T cells, like other T cells, they need picking up the allergen by antigen-presenting cells, processing the allergen, changing it to the peptides, and presenting the peptides to T cells, including regulatory T cells. So regarding the concentration of allergen in this study and different studies that they evaluated the efficacy of isopathic immunotherapy, it couldn't be happened for the isopathic immunotherapy. So our result confirmed that it wasn't and significantly increased in the population of regulatory T cells and its main cytokines transforming growth factor beta. So, but don't worry, there is another candidate, regulatory B cells. Actually, there are some evidences in favor of that we can consider them as the main and primary target of isopathic allergen immunotherapy. The activation threshold of regulatory B cells are lower than other cells, so a mild stimulation from isopathic immunotherapy can selectively just activate and stimulate regulatory B cells. They have regulatory functions. They don't need the help of antigen-presenting cells and processing and presentation of antigens. They can be directly activated and stimulated, and also their population increased in an inflammatory milieu. So whatever is in the high dilution of ovalbumin, we can propose, that is a suggestion, as a mild stimulation can stimulate regulatory B cells, and after that, regulatory B cells with the main cytokine, produced cytokine, I mean interleukin 10, can provide an anti-inflammatory and regulatory milieu that can control allergic asthma. And as the last slide, the result of this study has been recently published in the Journal of Asthma. Thank you very much for your attention.